All right, in this lesson, we are going to go over radicals. This is going to be a start of our radicals unit. And for this lesson, we're going to look at how can we simplify square roots and cube roots and get those things into their simplest form. So let's go ahead and get started. One of the things that this unit will use is our some vocabulary that we haven't gone over before. We've gone over a little bit in the warm up, and if you didn't get to do that one piece, it'll be available for you in Schoology. But we're going to be going heavy with some of these different vocab terms. But before we get to the vocab, let's go ahead and get started with our essential question. So since we're trying to understand how to simplify these things, that's going to be the basis of our essential question. So it's going to be, how can I express square and cube roots in their simplest form? All right, and when we say simplest form, it means, you know how when you think about fractions, there are factors that we can pull out of a fraction. It's kind of the same thing with these. There are factors that we can pull out of these radicals, and we'll get into what all that means in just a second. But that's what it means to get it into simplest form, where we can no longer pull any other factors out of the radical. And this is going to be an important part moving forward with this class. All right, so let's actually get into the notes. So first, let's go ahead and look at the basic vocabulary that we're going to have. It has nth, and then the square root indicates the nth root, and all that nth means it's just kind of a placeholder. That n could be a 2, it could be a 3, it could be a 10, it could be a 12. For this lesson, it'll either be a 2 or it'll be a 3. So we'll deal with squared roots, which is 2, or cubed roots, which is 3. Okay, this nth thing is what is called an index. Okay, and I'll see if I can do a decent job color coding this and writing on this n. That here is our index. And what the index is, it just tells us how many of a factor we're going to be looking for. So if you think back to those fractions, we pulled out factors to get it as tiny as we could. With this, there are a little more things we have to think about. And so that n tells us how many factors we're looking for to pull out. Next, we have the radical sign, which is going to be the thing that we've seen before, that square root sign. This portion here, this is our radical. Sometimes you'll see it as radical, sometimes you see it as radical sign. I'll mostly call it a radical just because that's shorter than saying radical sign each time. And then finally, we have this portion here, the number itself that is under the radical. This number is called the radicand, okay? Radicand. The radicand. Here's my mouse. I need to scroll. All right, there it goes. So far we've got our index, which we use for n index. Those two fit. Our radical sign, and then our radicand is the number underneath that radical. And so here it says the index indicates what type of radical it is. For example, as square root or cube root. Those are the two we'll be working in today. And then uh, the square root of 25. That's what this piece here is. What color did I use for radical? I think I used pink. Yeah. This pink color, use that right there. This pink color, if we don't see a number written, then we're just going to assume that it's 2. If it's not written out, then we know it's just going to be 2, because that's kind of what that means. It's just going to be 2. So the square root, and that's what we call it, that the square root. So this index here is always going to be 2. And we know that the square root of 25 is 5, because 5 times 5 is equal to 25. So that's what a square root says. How many times do you have to multiply something to get to the radicand number? When we're doing square roots, what number do you have to multiply twice to get to that number? And if you're doing cube roots, like we're doing right here, with this 3, if you're doing cube roots, what number do you need to multiply 3 times to get to this 8 as a radicand? And that's going to be 2. And there's going to be 2 times 2 times 2. This is something that may be a little bit tricky at first, but the more we do it, the more sense it will make. Okay? So let's look at some more of these examples. And if you need to pull up your Desmos to type these things into the calculator, it will help you out. I believe Desmos also has these features and functions where you could just input the square root and type your number underneath, or input something to the nth root and just type your index and your radicand, which is going to be that number, and your index is going to be the one that lives in that little divot. I guess I can call that the porch. So under this is the house. This 64 is under the house. And if there's nothing on this porch here, then we know it's going to be a 2. So we got a 64 in the house and a 2 on the porch. And that means, what do we multiply twice to get to 64? And what we multiply twice to get to 64, if you're good with your times tables and you remember those things, that's going to be 8 times an 8. And that's going to be equal to 64. Okay? This is something, if you need to go check in Desmos, definitely go do that. But this here, this radicand with this index of a 2, we don't write 2 because we just know 2 is going to be there. Anytime you see the house, I'll use the radical as that, the house with nothing on the porch, which is going to be that little divot in front, this piece right here, that's going to be the porch. If you don't see anything there, then we know it's going to be a 2. It's always going to be a 2. However, when we see something like this, where we have our house and we have a 3 on the porch, this little piece right here, this 3 is on our porch, we know that our index is 3, and we're looking for whatever number we can multiply 3 times that gets this radicand, this 27. The number in the house is the radicand, the number outside the house is the index. So what number can we multiply 3 times to get to 27? If you want to go type this into Desmos, that's cool. If you want to check and go up 1, 2, 3, 4, 5, 6, 7, and see whichever one it's going to whichever one it's going to be, you will find that it's going to be 3. Let me change colors for this part. You'll find that you're going to get 3 times 3 times 3. And what this is going to be 3 times 3, which is 9, and then times 3 is 27, okay? So the cubed root of 27, that's how we say that when we have the 3 as our index. When we have that 3 that's on that porch. The cubed root of 27 is 3. And I don't believe I said this one. The square root, this is what we call it when we have a 2 on the porch, but it's not going to be written. It's just going to be invisible. When we have that 2 on the porch, we're going to say the square root of 64 is 8. If you find a square root and you want to check it, you can just raise it to the power of that index. So to check this, I would take my 8 and then I would square it. And then whatever I got should match up with this thing. And that's because these two things are opposites, but I'm getting a little bit ahead of myself. So let's look at this next example. 81, this says the square root of 81. We don't have a number written in. There's nothing outside on the porch, so we know it's going to be 2. So the square root of 81 is going to be equal to 9. And that's because 9 times 9 is equal to 81. Or 9 squared is equal to 81. Okay? So that's how we think about these different things. We're dealing with cube roots and squared roots. So far, we've got our index, which is our nth root, or the number that's outside the porch. That number that's outside the porch is going to be like this 2 here, or this 3 here. Our index, outside, nth root, all those are the same. Then we have our radical. Our radical is going to be the house itself. This little doot, like a check mark with some extra stuff on it. That's our house and our porch. If you want to think about it that way, it has the porch and then the house covering. And then we have our radicand. Our radicand is the number itself. This is a 64 as our radicand. That's under the house. This one is a 27. That's our radicand. It's under the house. This one is an 81. That's our radicand. It's under the house. Okay. Now I know these can be a little bit confusing. So if you have questions on these first bits, because the vocab is going to be very important as we go forward, definitely take some time, pause it, watch it again if you need to, or come back to the Zoom chat and we'll help out. All right. So now we're going to look at the bulk of this lesson. It says for numbers that aren't perfect underneath the radical, we will use prime factorization to help us reduce the radical. And what it means by perfect is that there's going to be nothing left over once we figure out what we can multiply to get to that number. All right. It's just 8 times 8 for 64, 3 times 3 times 3 for 27, and 9 times 9 for that. When we don't have things like that, we're going to use this method, which is called prime factorization. Okay? That sounds intimidating, but it's not that hard. It uses what's called prime numbers. And you guys have probably heard of those before. Numbers that only have two factors. It's going to be 1 and then that number itself. Like the number 1, that's a prime number. The number 2, that's also a prime number. The number 3 is a prime number because you can't multiply anything together to get 3 or divide it by anything and get a whole number besides 1 and 3. Same thing with 5, same thing with 7, not 9. 9 is an odd number. That one can be kind of tricky, but you're not going to do that with 9. 10, nope, 10 is an even number. Anytime you have an even number, it can't be prime because it has 2 as a possible factor along with itself as a number and the number 1, and then some other number as well. 11, that also works. So if you can go on and on and on about these prime numbers, they're kind of fun actually. I won't get too much into it because that goes beyond the scope of our Algebra 1 class. But let's get back to the notes piece. When we don't have perfect numbers, such as this 48, we use what's called prime factorization. And the way that works, we're going to find what our index is first, okay? Our index here is not written, so we know our index is 2. If it is written, then you know it's going to be whatever is written there. That's like almost not even really a step, but it's something that we have to keep in mind. So our first step, number 1, says prime factorization. We're going to draw a line and always start with 1 and the radicand. Divide your radicand by prime numbers until you get to 1 on the right. So we're going to start with 1 and we're going to end with 1. If it doesn't make sense, just keep on paying attention and we will get there. All right, maybe try to draw a slightly straighter line than I did. So we're going to start with 1 on the right and 48 on the left. Then it says, write all the prime factors under the radical sign. So the way we're going to write all these prime factors under the radical sign is going to come after we finish with this prime factorization. So this may look like we're done. We're not quite done with this first step. So now we need to start with 1 and divide the radicand by prime numbers. Those first numbers I just listed. Prime numbers will be numbers like 1, that's a prime number. 2, that's a prime number. 3, 5, 7, 9. You shouldn't really have to go much higher than that, so we can do most of our math with numbers that are kind of small, but those are numbers that work that we can use. So we're going to start with this. 48 is an even number, so we can divide it by 2. That's a prime number. When we divide by 2, we get 2, and then what times 2 is going to be 48? That's going to be 24. So we have 2 times 24. 24 isn't 1. Our goal is to get to 1. So we're going to do this step again. What prime number can we divide into this? Once again, we get another 2. 2 times what gives me 24? 2 times 12 gives me 24. And this still isn't 1. It's 12. So what can we do? Divide by 2 again. And then what we're left with is that 6. And then divide by 2 again. And now we've got a 3. And here's where the interesting part is. We can't just go by 2, 2, 2, 2, 2, 2, 2 the entire time, because we get to stuff like this where we not at 1, but we have a prime number. So now what we're going to do is look for another prime number that we can divide by. And that prime number is going to be the number 3 itself. So 3 divided by 3 is 1. All right. So we started with this 1 here, and we've gone all the way down using our prime factorization to get to 1. To recap that process, that first step, we start with 1 and our radicand. Once we have those two numbers out, we're going to divide by one of our prime numbers. If it's divisible by 2, then if it's an even number, you're going to use 2. If it's an odd number, you may be able to use 3, 5, or 7. You kind of just got to try your math, plug it into Desmos, divide it by 3, 5, or 7 if it's an odd number, and see which one gives you a whole number. If it does, that's going to be your prime number you used that goes right next to it, and then the whole number that you got when you divided it. And this time it was 2, so we just went on through. And we did that for each different number we got. Now that we've done that, We are on step 2. Step 2, it's really easy after this part. Step 2 says write all prime factors under the radical sign. So what I'm going to do is I'm going to draw another radical sign. I'm going to do not the best one, but it works. We're going to write all the prime factors under the radical sign. The prime factors are going to be the numbers that are on the left side of this line, okay? So we're going to have 1, we're going to have 2, and now when you write these out, don't just write them out as a list of numbers. We need to multiply these things together. So it's going to be 1 times 2 times 2 times 2 times 2. So I got a 1 times 2 times 2 times 2 times 2, and then I have times 3. All right, and I checked them off just to make sure I didn't forget a number or I didn't add too many numbers in here. I recommend you all do the same thing. That's going to help you stay to be accurate. And once we have these things, step 3 says circle the pairs or triplets based on our index. Our index is 2, so we're going to circle pairs. I have a pair of 2s here. And let me do that in a different color, actually. Let's use this bright green. All right, so I'm going to circle this pair of 2s, and this pair of 2s. Now that I've got those circled, my step number 4 says one number from each circle goes in front of the radical sign, multiply. Everything else stays in the radical. So now that I've got these pairs, this is how we're going to think about it. These pairs, they like to go out. They like to go have fun with their mask, of course, because it's COVID-19 season. We're still in a pandemic. And they're going to go out together. So we have a 2 coming out to have fun. And then we're going to keep that multiplication sign along with another 2 coming out to have fun. But everybody else, they didn't want to come out. They didn't have any friends to go with, unfortunately. So they stay in the house. They stay under the radical. So we have this 1 times this 3. And so our final step, our absolutely final step, is to simplify. We have this 2 times 2, and then the radical, and then 1 times 3. And I'm going to switch this color. I know sometimes you all have trouble reading this color, the super bright color, so I'll use this black. And then our finally we end up with 4, because that is, let's draw arrow. Actually, I won't draw arrow. We have this 2 times 2, which is 4. I'll try to get it more. 4, and then, yep, 2 times 2, which is 4. And then we have the radical, and then 1 times 3 is just going to be 3. Okay, that's how we do this. And that seemed like a lot, but we've got a few more examples. I'm going to do a couple, then I want you all to try a couple on your own, okay? So once again, if you struggle with that, or if some part you got lost, go back, pause it, rewind it, watch it again. It's the reason we do videos. And then if you're still stuck, still struggling, come back to the Zoom chat and I'll try to help walk you through the process, okay? But let's look at our next example. Excuse me. This says the square root of 120. Now I know that this is the square root because we don't have anything on this porch. The porch is empty, and so since the porch is empty, it's got to be 2. We just know it's always going to be 2 anytime our porch is empty. So our index is 2. Got nothing on the porch and a 120 in the house. So now what we're going to do is we're going to do our prime factorization. All right. You start talking about prime factorization with your parents and your friends, and like, wow, you're good at that math stuff, huh? Well, really, it's pretty easy. All right, so we start with 1, and then the radicand, the number that's in the house. So we're gonna have 1, and then 120. Okay? So when we do this, 1 and 120, what number goes into 120 evenly? It's gonna be 2. Okay, so we're gonna have 2, and then how many times? It's gonna be 60. And one of the ways you can do this, we like to try to think about multiplication, but if it's easy for you to just figure out what number divides and you don't get a decimal, do it that way. What number can you divide? What prime number can you divide into our radicand and get a whole number? That's how we're going to do it. So 120 divided by 2, 60, and then 60 divided by 2, it's going to be 30. And you may think, hey, Mr. Williams, isn't 5 a prime number that's bigger than 2? Wouldn't that work? 5 would work. Okay, the reason we stuck with 2s is that it kind of makes things simpler in the long run. If we did 5, We do 5. That's going to be 5 times what? 6 is 30. And then we end up with a 2 and a 3, and then a 3 and the 1. All right, and the reason we don't jump around like that is because you see how we got 1, 2, 2, 5, 2, 3. It gets a little funky and harder to keep track of, so that's why I recommend if we can use 2s, go ahead and use 2s because it'll keep things simpler in the end. Okay. In this case, it doesn't matter too much. 2 divided 30 divided by 2. That's what I meant. Not 2 divided by 30. So we got a 2 and then a 15 because 30 divided by 2 is 15. And then here's where the 5 comes in. 15. We could do 3 or 5. Honestly, either one works at this point. It doesn't matter. Both of those are going to give you prime numbers to work with. I'll do 3 though, just to go in decreasing numerical order. 3, 5, and then 5, 1. All right, so now we've got that part done. My next step is to write them all underneath the radicand. So I have 1 times 2 times 2 times 2 times 3 times 5. And I'll write that and then I'll just go through just to make sure I got them all. 1, 2, 2, 2, 1, 2, 3, 2, 3 2s. All right, a 3 and then a 5. Yep, I got them all, didn't miss any of them. Now that we've got these, we're going to circle the pairs. Circling the pairs leaves me with just a pair of 2s. These 2s want to go out and have fun, so they come on the outside, and we end up with 2 on the outside with 1 times. We still have a 2 on the inside because I didn't have a pair. A 2 times a 3 times a 5, okay? And I know that's kind of hard, so I'll go back to a normal color. And once we get to that part, we're going to simplify with 2, and then we multiply these things that are under the radicand, or that are the radicand, that are under the radical. We're going to multiply the things that are in the house. All right, 1 times 2 is 2, times 3 is 6, 6 times 5 is 30. Okay, so the square root of 120 is 2 square root of 30. That's what it's going to be equal to. All right, so that wasn't too bad. I'm going to do one more. I'm going to do one more so you guys get an idea of what it's like for 3s, and then I'm going to leave the other 2 for you all for practice. So example next, right underneath the one we just did. It says the cubed root, that's how we say it when we have a 3 on the porch. If you want to think of it that way, that's how we say it when we have an nth root of 3, if you want to think of it like that, or we have a 3 as an index. That's what this means. This 3 here, this 3 on the porch means we have an index of 3. And so when we're doing this one, we're going to look not for pairs, but for triplets. Triplets, the bits of 3, okay? So let's look at this. Let's get started on this 3. Yeah, I'll keep writing in red. First, draw that line. We're going to start with 1 and our number. Our number here is 48. So when we have 48, this looks kind of familiar, doesn't it? Didn't we do 48 once before? We have 48, and we divide by 2 because that's an even number. When we divide by 2, we get 2, and divide by 2, and we get 24. Or you can think of it 2 times what is 48? 24. Then we can take a 2 out of this too. 2 times what is 24? It's going to be 12. 2 times what is 12 is 6. 2 times what is 6? It's 3. And right on the line. What times what is 3? 3 times 3. Or 3 times 1 is 3, okay? 3 can only go to 3 one time. There we have it. We've got these numbers. And our next step is to go ahead and write out our radical. You know, I didn't have much rhyme or reason with these colors this time around. I don't like that. I have to do that better next time. We write these numbers back out and the radical, under the radical, 1, 2, 2, 2, 2. Oops. And all these are multiplied together in case you don't know. 1 times 2 times 2 times 2 times 2 times 3. And now I'm going to just go through and double check. I got 1. Yep. Got a 2. Yep. Got another 2. 2 2s, 3 2s, 4 2s, and 1 3. All right, and so now I'm going to start, instead of circling three of them, I'm only going to circle, I'm sorry, instead of circling two of them, I'm going to circle three of them. The index is three, and so we're looking for triplets, 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 not pairs. So three, one, two, three. I see a group of three here. That's what we have. They're going to come out. And what we end up with next is this two on the outside. We don't write two three different times since we were looking for a group of three to come out. They come out as one group and they stay on the outside. And then we keep the rest of those numbers under the radical, under the radical. Talking is hard sometimes, y'all. 2 square root 1. We still have a 2 under there, and we still have a 3. All right, and so finally we simplify. That 2 doesn't have anything multiplied to it, so it stays at 2. And then we have 1 times 2, which is 2, times 3, which is 6. 2 square root of 6. That is our answer for what is the square root of, or not the square root, what is the cubed root of 48, okay? So our answers can change based off of what our index is or what that number on the porch is, because our groupings may change. We may be looking for two things or we may be looking for three things. So this one had a lot of new things, or mainly one big new thing that we had to cover, and that was vocabulary. The vocabulary was kind of difficult, so make sure you're paying attention to the vocabulary. If you get stuck, come back to the Zoom chat, ask a question, we will help you. When you finish this, go ahead and write in the summary. What was that muddiest point? Where'd you get confused at? What part lost you completely? And then how did you get to your answer from there, okay? Make sure you get that done. Once again, if you need help, come back to Zoom chat and ask. That's what we're here for. And then once you're done with that, go ahead and get started on the next bit of the classwork, all right?